Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In today's video, we will discuss the geometric transformations of the graphs of functions. But before we start off with learning how to perform these geometric transformations, you should know how to perform the transformations of stretch and translation. First of all, talking about translation, it is just like moving a figure from one position to the other position. Here, mostly we will be doing either horizontal translation or vertical translation. If you're doing translation parallel to the x-axis, so that means every coordinate is going to move horizontally by that many units. So you just add the vector of translation to every coordinate with x and 0. So here I'm doing the translation parallel to the x-axis. So if this is my original figure and I have to translate this figure horizontally, it's going to move rightwards if your translation vector is positive. So if I have to translate it by 2 and 0, so every point is going to move 2 units to the right, and this is going to be your transformed figure. Similarly, if you have to do translation by a vector of -2, 0, so that means every point is going to move leftwards by 2 units. So this is going to be your image if you would translate it by -2 and 0. Similarly, if you have to translate a figure parallel to y-axis, and if this is your original figure, this is going to be your translation vector. That means that you will add as many units as you have to translate to the y coordinates. So if the translation vector is 0, 2, so that means every point is going to move 2 units up. And this is going to be your transformed figure after moving every point 2 units up. Similarly, if you have to translate it downwards, that will be represented by a vector 0, -2, and that means that every point is going to be shifted 2 units downwards. So there are 2 possible translations that you would be doing, either a translation parallel to x-axis where you will add the number of units of translation on the x coordinate, or you have to do the translation parallel to y-axis where you will add the units of translation to the y coordinate. In case of translation parallel to the x-axis, the figure is going to move horizontally, and in case of translation parallel to y-axis, the figure is going to move vertically, either up or down. The second transformation that you must be able to perform is a stretch. So what you actually do is that you will be having a particular stretch vector, and with that stretch vector, what you do is that you multiply the distance of the point from the axis and you multiply it by that stretch factor, and that will give you the new distance of that point. So if I want to do it by a stretch vector of 2 parallel to y-axis, I can see that the original figure has a distance of 2 units from the x-axis. So I'm going to multiply it by the stretch factor and it becomes 4. Similarly, this distance is 2, I multiply it by 2 and it also becomes 4. And this point has an original distance of 4 units, which gets multiplied by 2 and it's going to become 8. And that is how I will be able to stretch a figure parallel to y-axis. I can also be doing stretch with the factor which is less than 1, the figure ends up becoming smaller, but I still do the same process. If this distance is 2, I multiply it by the stretch factor half, so that becomes 1. Similarly, if this distance is 2, I multiply it by half, it again becomes 1. Likewise, if I look at this distance, which is 4, and I multiply it by half, it becomes 2. So this is a stretch with a stretch factor bigger than 1, and this is also a stretch, but the stretch factor is smaller than 1. You can similarly stretch figures parallel to x-axis as well. In that case, you will see the distance from the y-axis and you will multiply that distance with the stretch factor to give you the new distance. Like in this case, if I want to stretch with a stretch factor of 2, I know its original distance is 3, that gets multiplied by 2 and it becomes 6. Similarly, if I look at this point whose original distance is 9, so I multiply 9 by 2 and that distance becomes 18. Similarly, if I look at this distance, this is 5 and I multiply 5 by 2 and that becomes 10. So that's how I can stretch the figure parallel to x-axis. I can again be doing stretch with the stretch factor lesser than 1. Like in this case, if the stretch factor is half, I can see that this distance is 5. Multiplied by half, it becomes 2.5. Similarly, this distance is 3. Multiplied by half, it becomes 1.5. And this distance over here is 9 multiplied by half, it becomes 4.5. So I can do stretch parallel to x-axis or parallel to y-axis. Stretch factor 1 means the figure does not move at all. But if the stretch factor is bigger than 1, then the size of the figure increases. If the magnitude of the stretch factor is smaller than 1, then the size of the figure would decrease. Now let's relate these concepts with the idea of the transformation of graphs of functions. What you need to understand is that if you already have a graph of function fx and you have to sketch a graph of fx plus a. So you can see this is your range and a constant is being added to the range, which is y. Whenever you see something like this, that means that you will add these many units to the y coordinate, and this will cause the graph to shift vertically. So if you add a, it's going to go up by that many units. If you subtract a, it's going to go down by that many units. So fx plus a means graph will go up vertically by a units. So you can see, I mean, every point will show a vertical shift. So if this point goes up, its x coordinate will remain same, but k will have a added to it. So this point is going to become h in k plus a. Even this point is going to go up. The x coordinate would still be alpha, but y coordinate, which was originally 0, is now going to become a. So it becomes alpha and a. Similarly, this point goes up and it becomes beta a. If there was an a subtracting over here, then I would move by a units vertically downwards. Now, you have to obviously closely see the difference between this transformation and this transformation. Here, the a is added to the value of range, fx. But here, the a is added to the domain. So if you ever come across this kind of a transformation, where you see the a is being added to the x value, then in that case, your translation is going to be parallel to x-axis, which means your values of x will change. There's also one more thing very important to identify, which is that if you have a units being added over here, and you always do that with the transformation of domain, what it seems like you have to do the exact opposite of that. So if you have to find out, or if you have to sketch a graph of f of x plus a, then that means that you have to translate the graph by a units towards left. Your translation is not going to be plus a, your translation is going to be minus a. So I can try and give you a bit of an idea of that. So if I take two functions, f of x is equal to x squared plus 1, and I take another function, g of x is equal to x plus 2 whole square plus 1. So if I put x as 0 over here, then I will get my range as 1. And you can see this function has a translation of 2 onto it. But when I put 0 over here, I get 1. But to get a 1 in this function, I have to put minus 2. When I put minus 2, then I get 1. So that means that the value of y will repeat for x plus 2 when I move 2 units to the left, which means that this entire graph is going to be translated leftwards. The most important takeaway over here is that if something is added to x, then that means you do not move the graph horizontally rightwards, you actually move the graph horizontally leftwards. And similarly, if there was a minus a over here, instead of translating the graph to the left, I'm going to have to translate the graph to the right. So in this case, if I know that I have to sketch a graph of f of x plus a, that means every point is going to move leftwards, translate leftwards by a units. So that means the previous intercept was beta comma 0, and you will subtract a from it, so it is going to become beta minus a comma 0, and similarly this is going to become alpha minus a 0. Similarly, the turning point is also going to shift leftwards, and if it was originally h and k, it's going to become h minus a and k. So the final verdict, that whenever you have to add to the range, you actually move the graphs in the same direction. If you're adding to y value, you go up. If you're subtracting to the y value, you go down. Whereas when you are adding something to the x value, instead of going right, you will go left, and when you're subtracting something, you will go to the right. Similarly, if you're given a graph of fx and you have to multiply it by a, this is the stretch parallel to y-axis. So if you have a multiplied to the range, so that means every value of y gets multiplied by a, which means that if you will look at every single point, it's going to multiply by a, and then that will be the new distance. So you can transform every individual point by multiplying it by a. But you would know that the x-intercepts are going to remain at their original place. They are not going to move because you are just multiplying a with the y-coordinate. So the alpha comma 0 remains alpha 0, the beta comma 0 remains beta 0. But if you multiply this coordinate by a, the x value will remain same and the y value gets multiplied by a. So this y coordinate is going to become h comma ak. So if this factor is bigger than 1, then the graph goes further away from the axis. But if this factor was smaller than 1, then this graph would come close to the x-axis. And likewise, just like you had this thing in the translation, you also have this thing in stretch along the x-axis as well, that if you have to sketch a graph of ax, here you're multiplying a by the domain. So if you have to sketch a graph of ax, instead of multiplying the values of x by a, you actually divide by a. So that means it's going to be a stretch parallel to x-axis, but with the stretch factor, not a, but 1 upon a. So that means every distance is going to be multiplied by 1 over a from the y-axis. So the distance beta becomes beta by a. The distance alpha becomes alpha by a. And similarly, if the turning point is h in k, then the x coordinate gets divided by a, so it becomes h upon a, and the y coordinate remains same, which is k. So summarizing everything we've discussed till now is, if I will add something to the y coordinate, that will be translation parallel to y-axis. So if you have f of x plus a, then it will be translation with the translation vector 0 and a. And if you have to do afx, then that will be stretch parallel to y-axis with factor a. These are the transformations parallel to y-axis. But if you have to do f of x plus a, then that will be a translation that's going to be 0 minus a. So it will be the opposite. Similarly, if you have to do afx, so that will be stretch parallel to x-axis with factor not a but 1 upon a. Let's have a look at few examples, like if I have to sketch a graph of fx equals x plus 1 whole square minus 4. I know that the coefficient of x square is positive, it should be a minimum turning point quadratic curve, and I also know that starting point is going to be minus 1, minus 4. So I can sketch this original graph, that's pretty obvious, but now I have to do transformations. So if I have to do fx plus 2, so that means I'm gonna shift this graph, translate this graph vertically upwards by 2 units. So every point on the graph is going to shift vertically upwards by 2 units. Whereas if I have to sketch a graph of f of x minus 3, now please notice the difference. Here 2 is added to the range, whereas here 3 is subtracted to the domain. So I have to translate horizontally, but also instead of subtracting 3, I'm going to have to add 3. So from the original graph, every point is going to move 3 units to the right, and that's how I'll get the transformed graph. Similarly, if I have to sketch a graph of 2 times fx, so that means this is basically a stretch parallel to y-axis. So every value of y is going to be multiplied by 2. Whereas if I have to sketch a graph of f of 1 over 3x, so instead of multiplying by 1 over 3, I'm going to divide by 1 over 3, which in turn gets multiplied by 3. So that means every value of x is going to be multiplied by 3. So wherever, if you can spot any value of x, that's going to be multiplied by 3, and that will give you the new point. For every individual point, x will be multiplied by 3, but that corresponding y coordinate will remain same. Now, when you have to do combinations of transformations, so you have to be careful with the order. So when you are doing transformations in the range, then you have to identify that first you perform stretch and then you do translation. So if you have to do transformation in the y-axis, then first you will stretch by the stretch factor A and then you will translate by B. But just like with everything over here, even in domain, you have to do it in the opposite order. So if you have to do f of ax plus b, that is, you have to transform the domain. That means that first you will translate by minus b, and then you're gonna stretch by 1 upon a. So here the order is going to be different. In case of range, you do first stretch and then translation, and in case of domain, you do first translation and then stretch. And if there is a situation where you have to do transformation on both domain and range, then first transform along the domain and then go for the transformation along the range. So if I would look at these and I have to explain the transformations along with the order, so I'm going to say first it's going to be a stretch parallel to y-axis with stretch factor half, and then it's going to be translation with the vectors 0 and 3. If I have to explain this, it's going to be a stretch parallel to y-axis with stretch factor minus 1. Minus 1 is just simply a reflection of the graph along the axis. And then I have to add 2 on the y-axis. So it's going to be translation with the vectors 0, 2. If I have to do 2fx minus 8, first is going to be stretch with stretch factor 2 parallel to y-axis, and then there's going to be a translation of minus 8 along the y-axis. So it's going to be 0, minus 8. But now notice the difference for this one. If you have to do f of 2x minus 6, then you will do first translation not of minus 6 but of plus 6. And then you will do stretch parallel to x-axis with factor not of 2 but of 1 upon 2. So you can see how we would rather be doing that. If I know this is the original function and I know its original graph, which is drawn with green over here, if I have to do 2fx minus 1, I'm going to first do stretch with the factor 2. So these are the results of points being stretched with the factor 2. And then I'm going to subtract minus 1. So once I have gotten all of these points along the red dashed curve, I'm going to shift it downwards by 1 unit. But if I have to do f2x minus 1, first I'm going to translate it to the right. It is minus, but I'm going to translate it to the right by 1 unit. So you can notice every point moves by 1 unit to the right. And then I'm going to stretch it parallel to x-axis with the factor half. So if this distance after first transformation is coming out to be 2 units, it's going to be half of that, which is going to be 1. So every distance, like if you will see this distance is 4, after transformation this is going to become 2. This was 0, so it stays 0. So that's how you will do combinations of transformations. Now we can have a look at few more examples. I have a function f of x is equal to x squared minus 2x. I had to originally sketch that graph, and then I had to sketch a graph of fx plus 2. So that means I'm going to shift it 2 units vertically upwards. And then I had to sketch a graph of fx minus 3. I'm going to shift it rightwards by 3 units. So this graph is going to move right by 3 units, and this is going to be a transformed result. If I have to sketch a graph of f of 2x, I'm going to do a stretch with parallel to x-axis and stretch factor half. So this distance 2 is going to be half and it's going to become 1, and this is how the result's going to look like. If I have to do minus 3fx, so that means I'm going to have to do, it's like minus for reflection, and then every point, like if this distance is 1 unit to the down, after multiplying by minus 3, it becomes 3 units to the up. That's how you will do the reflection along with stretch. So if you have a negative stretch factor, so that means you have to do both stretch and reflection together. Or you can do it in 2 steps as well, that with the minus sign you can just simply reflect, and after reflecting, like if this is your original graph, first you reflect it with the minus and then you can multiply it by 3. So this is going to be a result after that. But in case of f of minus 1 over 3x, you're going to multiply x values by minus 3. So that means if something is 2, it's going to become minus 6, and 0 will stay to be 0. And this is how the transformed graph is going to look like. F of x plus 1 plus 4, here you have to do true translations. You have to do translation along the y-axis up 4 units, and you have to do translation along the x-axis left 1 unit. So you move it left 1 unit and up 4 unit, and this is going to be your transformed graph in this situation. Let's have a look at an example question. First, it was being asked to sketch the graph of y is equal to 1 over x squared. I can identify that this is how the graph of 1 over x squared looks like. The curve is translated by 3 units in the negative x direction. So I know it shifts to the left by 3 units. State the equation of the curve after it has been translated. Since I'm translating it to the left by 3 units, I'm going to add 3 to the value of x. So you can see that the x squared becomes x plus 3 whole square. And then it says the curve y is equal to 1 over x squared. It's stretched parallel to y-axis with the scale factor 4. The point 1, 1 is transformed. If you are doing it parallel to y-axis, so that means you will just simply multiply y coordinate with the stretch factor of 4. So that means 1 becomes 4 and this one remains as it is 1. Let's have a look at another example. First part, we have to sketch a graph of y is equal to minus x cubed. This is how a graph of minus x cubed looks like. And then it says the minus x cube is translated 3 units in the positive x direction. Find the equation. So if you're shifting it 3 units in the positive x direction, you will subtract 3 from x. So that's going to become x minus 3 whole cube. And then it says describe a transformation that will transform the curve this into this. So you can see the y value is getting multiplied by 5. So it is a stretch parallel to y-axis. X-axis is the invariant line. And the curve already has a minus sign in it, so the stretch factor is going to be 5. So guys, this is a past paper question from June 24/11. This is a trigonometric graph that's being given to you. It says the diagram shows 2 curves. One curve has an equation y is equal to sine x, and the other curve has an equation y is equal to fx. In order to transform the curve y is equal to sine x, which is this curve, the curve is first reflected in the x-axis. describe fully a sequence of 2 further transformations which are required. So you can see all of these are along the y-axis, and once we identify that this is the original sinus graph, it gets reflected. It has already been told in the question, so that would be my first transformation. But to do the remaining transformations, I can do a bit of an inspection and I can identify, and you know that whenever you're doing it along the y-axis, you will first do stretch and then you will do translation. So you can see that if this 0 is going down to -2, then your translation must be of units 2, because the 0 is not affected by the stretch. So that means if your translation must be of -2, so that means this point goes to this point, and which means that the stretch factor in this case is going to be 3. So first it's going to be stretch parallel to y-axis with stretch factor 3, and then it's going to be translation parallel to y-axis by -2 units. So one thing you must know from before, that has to be stretch followed by translation. And you must know that the point 0, 0 is not going to be affected by stretch. That clearly tells you that the translation is by 2 units. But if this point 1 has gone down to 5, in which 2 is the translation, so the remaining 3 must have been due to stretch. So the stretch factor is 3, and then the translation is by 2 units. And that's how you can figure out the 2 transformations after the reflection. And then we have to state the equation of the function, and we can sort of identify that a reflection and stretch of 3 would be -3 sin x, and a translation of 2 would be -2. Let's have a look at another question. We have in the curve equation y is equal to x squared, and it is transformed into y is equal to 4x minus 3 whole square minus 8. So you can identify that you have different transformations going on over here. You'd always prefer the transformation of domain first. So a -3 means that's a translation with the vector 3, 0. And then in case of y-axis, you first do stretch. So you have to mention the stretch parallel to y-axis with the stretch factor 4. And after you have done these 2 transformations, and there is a translation along the y-axis with 0, -8. In another question of November 2023, it says the transformation R denotes a reflection in the x-axis, and the transformation T denotes a translation of 3 and -1. So you know that x translates by 3 to the right, and y translates by -1 downwards. So we have to find the equation of the function of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations r followed by t. So r followed by t, first it's a reflection, so it's going to be multiplied by minus. And then you have to identify that the translation parallel to x-axis is 3 units to the right. So that means there will be a -3 over here. And the translation on the y-axis is -1 unit. So it will be as it is -1. Then it says find the equation of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations t followed by r. So that means first you do translation and then you do transformation r of reflection. So that means there will be translation along the x-axis, which will be x -3, and then the translation along the y-axis, which is going to be -1. And then since after that you do the reflection, you're going to multiply it by -1, and this is going to be your final equation. And then it says describe fully a single transformation that maps gx onto hx. So if you compare these two, you can only see that this -1 becomes 1. So you have to add a 2 on your range to make it become like this. So that's a translation of 0 and 2. So guys, for another question, I've been given 2 functions, y is equal to fx and y is equal to gx. And it says describe fully a sequence of 2 transformations which transforms the graph fx onto gx. So I can see that my y values are getting increased. So I know that this is going to be multiplied by a 3 would be multiplied by 2 to become 6. And similarly, -1 will be multiplied by 2 again to become -2. So that means the stretch is with stretch factor 2 and parallel to y-axis. And then you can do translation first and then stretch. It's gonna be fine either ways. And then you can identify that this is getting translated by 6 units to the left. So this is going 6 units to the left. So that means that the other transformation is going to be translation of -6 and 0. Have a look at another question. It says there's a figure ABC and that transforms onto the figure A prime, B prime, C prime, and we have to identify 2 successive transformations. So we can see it's a stretch parallel to x-axis, and this distance 2 becomes 4. So that means for the transformation, the stretch factor is 2. And after it getting stretched, when B point comes here, then I have to move it down by 2 units. Similarly, A point comes here, and then I have to translate it by 2 units down. So that means there's a translation of 0 minus 2 as well. Guys, have a look at one more example. It says a function is defined by this. A sequence of transformations is applied in the following order to give the graph of y is equal to gx. So you see, you have been told it's a stretch parallel to the x-axis with stretch factor half. So if it is a stretch parallel to x-axis with the scale factor half, that means that you will multiply x values by 2, not half. So that's going to be every value of x is going to be multiplied by 2. And then you have to do reflection in the y-axis. So that means if you have to reflect any point in the y-axis, your x coordinate gets multiplied by a minus sign. So that's why there's a minus 2x whole square and minus 2 times. So every x gets replaced by minus 2x to perform these 2 transformations: stretch parallel to x-axis with stretch factor half and reflection in the y-axis. And then afterwards, you have a stretch parallel to y-axis, stretch factor 3. Y-axis is pretty straightforward. You multiply the entire function by 3, and that will give you the transform function. I mean, these are the constants that had to be determined. So you can see that your function is coming out to be in this form, where A is comparable to 12, B is also comparable to 12, and C is comparable to 15. So guys, I hope this was useful towards understanding how to perform linear transformations in the graphs of functions. Guys, if it did help, I'd really appreciate if you give a thumbs up to the video and also subscribe to my channel. Thank you.